Mikrofon është optical illusion, se veç me kamerë funksionon, ju kështu s'keni naj funksion. Do të me prit mastrën për të jap një pozim. Jemi gati, a? Okej, atëherë faleminderit shumë gjithmonë që vini këtë numër të madh, sot është një vazhdim i temave tona që na e quajmë Diaspora Talks. Shpeshherë po marrim kritika për këtë efektin brain drain, qysh po rrisim talente, po ikin jashtë dhe një farë forme po humim, mirë po është kënaqësi kur shohim edhe marrim gjithmonë ekspert ton të vendit, cilët me të vërtet kontribuojnë edhe jo vetëm japin ide, po sjellin edhe risi të reja dhe rrisin rrjetin ton të profesionistëve në mënyrë që ne si komunitet po dhe si vend me pas një zhvillim mas shpejt dhe të mas qëndrueshëm. Me Visarin, i cili sot është mysafiri ynë, kemi pas moti diskutime. Tash në këto 10 vitet e fundit një CK kemi pas kënaqësinë edhe mundësinë, po edhe kënaqësinë me pas shumë ekspert të fushave ndryshme, cilët kanë dhënë një kontribut, çfarë do të qoftaj në ICK dhe për komunitetin e gjanë. Kemi betimin, kemi labin e shumë tjerë cilët janë prapë sot me ne profesorin duke qenë e krejt tjerë. Patëm qef sot me hap një temë të re, me një mysafir të ri cili s'ka pas mundësi me qenë në ICK, nështë në Kosovë po me prezentim, kështu që këtë takimi sot që më është i këtij formati, kurse me Visarin kemi me pas mundësi me bo dhe aktivitete tjera, për cilat po shpresoj kanë me metë befasi e këndshme javën VM. Visari e ka spjegu, nuk na la shumë befasi këtu, është profesor, associate professor në College of Engineering edhe në College of Health Solutions në Arizona State University. Me ta është edhe vetë profesorin Derum, baba i vetë, i cili pashtu është profesor në njëjtin universitet. E për krejt këto Visari, nashta pak e bën intro për vetën e për familjen, për shkak se është shumë e çmueshme me dëgju ajo pjesë për me bën dhe lidhjen sigurisht me pjesën edhe për cilën sot jemi mbledh. Visar, gjithmonë faleminderit shumë për kontributin që e jep. Unë po shpresoj që ky është një fillim i një bashkëbisedimi cili ka me zgjatë edhe ma shumë, edhe për cilit presim që komuniteti me përfitu, po të njëjtën kohë me pas një bashkëpunim ma të madh. Faleminderit shumë. Një aplauz atëherë për mysafirin.
Faleminderit shumë.
Pyetje teknika, duhet me majta, është okej?
Ka një tjetër për ndo, këtë mirë është.
Okej. Pas ka një si gjenë.
A kënon pak ma mirë për ndo. Nëse falenderët Oranik, falenderët për ftesë, edhe sot me shumë kënaqësi do të flas për artificial intelligence. Kisha pas qef para se me fillu, sipas sugjerimit të Oranikut, me shpjegu pak për historinë, ndoshta historinë time, po edhe të familjes, qysh kemi mrinë në Amerikë, qysh kom hinë këtë ami. Në vitin 91, patëm dalë prej Kosovës edhe kemi shku në Arizona. Prej 91-ës jam atje përveç një 2 vjetë që këm pas jetu në Boston. Arsyeja që patëm shku është për shkak se baba e ka fitu një bursin Fulbright, e prej atje do me thonë një më shkollu prej klasës 5 të më tutje. Mirë po, si kur që thash edhe dje me një intervist, 80% seneve që i di me mësojnë para moshës 10 vjeqare, kështu që shumicën e seneve që i di kom mësu qëtu në Kosovë, në shkollën Dardanin, është edhe në Tëbhane edhe që aty ku kemi banu. Atje kom kry fakultetin, në PhD e kom bo në Speech Signal Processing, dhe me thonë procesimi e zërit në using artificial intelligence. Mandej kom shku një postdoc e kom bo në MIT. Pas asaj kom punu në industri disa vjetë dhe tash jam në prej 2013 në Arizona State University si profesor. Si profesor në fakultet, faktikisht i ki 2 role që i lu. Një si teacher, you teach classes, tjetëri si hulumtus, të me thonë, you develop a research program edhe bën hulumtime me një drejtim për cilin ka nevojë. Në 10 vitet e fundit, kjo artificial intelligence ka qenë diçka, është bërë një boom në këtë drejtim, edhe sidomos ndoshta 6 muajt e fundit, 1 vitet e fundit kanë dalë disa rezultate shumë të reja që janë të hatashme. Edhe do të flas sot për çato rezultate, do të flas për çato algoritme, edhe ta shpjegoj pak a shumë se si punon AI, po mirë po jo në mënyrë shumë detale, jo me shumë detale, po very high level. Ndoshta ma falni, po prezantimi është në gjuhën angleze, më vjen shumë vështirë me fol për tema teknike shqip, mirë po nëse keni nevojë për ndonjë sqarim, lutem vetëm tregomni. Kishte me qenë mirë me konë prezentimi edhe interaktiv, kështu që I bëj do pyetje, mos t'i vjen marrë. Okej, po fillojmë. Okay, welcome everyone. Today I'll be talking about artificial intelligence or AI. AI is a hot topic these days, and it's not hard to see why. With all the recent advances in technology, it seems like anything is possible. And that's really what AI is about. It's using computers to do things that would normally require human intelligence, like understanding natural language or recognizing objects. AI is still in its early stages, but it's already changing the way we live and work. In the future, it'll only become more ubiquitous. So that's a brief introduction to AI. I'm sure there's lots of questions, so let's get started. This is a really unusual way to start a presentation where you're just reading from a slide. So I didn't write this. This is written by a pre-trained AI model called GPT-3 from a company called OpenAI. And the way that it works is you provided a prompt. The prompt is what I wrote on top. I'll be giving a presentation on artificial intelligence to a diverse audience. Write a script for how I can introduce the topic of AI to the audience. And this is what it wrote. It's not perfect. I would have not written it exactly like this, but it's pretty damn close. I mean, this is good. This is good. So that's why I started the presentation this way, to kind of showcase what's possible. Let's do a couple more examples with GPT-3. Okay, this is the prompt. What does Innovation Center Kosovo do? Please list some of the successes they've had. Who's expecting a good response here, and who's expecting gibberish? Who's expecting a good response? 4 people, 5, maybe 10 people, I don't know. Who's expecting for the AI to get completely confused here? Yeah. Okay, so Uranik, tell me if it did a good job. The Innovation Center Kosovo is a nonprofit organization that promotes entrepreneurship and innovation in Kosovo. They do this through providing training and support to entrepreneurs, connecting them with mentors and investors, and organizing events and programs. Some of their recent successes include launching the first ever accelerator program in Kosovo, connecting over 100 entrepreneurs with mentors, and organizing the first ever startup weekend. Is that right?
Yes.
Yeah. How did it know that? Pretty amazing. Okay. Let's do one more. Let's see if it knows math. There are 17 kids in a school bus. All kids either have blue shirts or red shirts on. If 8 of the kids have blue shirts on, how many kids have red shirts on? Think through this step by step. Okay, who thinks it knows math? Okay, more hands after the last one. All right. Who thinks it doesn't know math? There's no way it knows how to do this. Okay, one person still non-believer. Okay. There are a total of 17 kids on the bus. 8 of those kids are wearing blue shirts. That means that the other 9 kids are wearing red shirts. So, I mean, it's pretty amazing. Like you can write any prompt and you get a response, right? So the first time I used this model, I got access to it last year sometime, and I was thoroughly amazed. Like the responses that you get are unlike anything I've ever seen before. I wasn't the only guy who was amazed. Google has a similar model called Lambda, and one of the engineers that was working with Lambda started interacting with it and became convinced that it's alive, it's sentient, and it has feelings, and that it has human-level intelligence. So the guy wrote a manifesto and posted it online, talking about how we need to protect the AI because it has human-level intelligence, and this is like another person. We have to treat them like we treat human beings. Anytime you're thinking of writing a manifesto, don't do it. There's like nothing good has ever come out of a manifesto. So he got suspended from Google for making these claims, and so now he's at home, I guess. But he still thinks that the Lambda, this equivalent of GPT-3 at Google, is sentient. This is nothing new. People have been studying artificial intelligence for a long time. The very first model that kind of resembles the neural networks that we use today was called the Perceptron, and that came out in late 50s. So here's an article from the New York Times in 1958. The guy that invented this perceptron, he said that the machine would be the first device to think as the human brain. As do human beings, perceptron will make mistakes at first, but will grow wiser as it gains experience. So there's always this temptation to talk about AI in human terms. This perceptron is, you can explain to a 5th grader how it works. It's very simple mathematics, and it performs a very simple operation, and it's nothing like the human brain, but nevertheless, because of this adaptive nature, where you show it data, it makes mistakes, you correct the mistakes, people like to draw connections between human intelligence and artificial intelligence. The purpose of the presentation today is, by the time we all get out of this room, none of you should believe this. Like, you should, hopefully, you'll see that it's nothing more than mathematics at scale, meaning imagine being able to train a model to process all of the text data on the internet using really simple math. I mean, I shouldn't call it simple. Using math, but implemented at scale, that process gives rise to these amazing models. If you don't believe me, let's do some more examples. OK, here's a similar problem. There are 17 kids on a school bus. All kids either have blue shirts on or red shirts on. If 8 of the kids have blue shirts on, what is the bus driver's name? Let's think through this step by step. So if you ask any 5th grader, any 4th grader to solve this question, they would say what? Like, it's not answerable. There's not enough information. Let's see what GPT-3 does. Well, first, who thinks that the model is going to get it right? That it's going to say there's no way to answer this question. OK, we got 5 or 6 people. Who thinks it's going to get it right? OK, there's a lot of hesitancy. Like, of course, it can't get the bus driver's name. By get it right, I mean to say that there's not enough information to. That's a different story. Yeah. Let me reframe it. Yeah. Who thinks the AI model is going to say there's not enough information to solve this problem? OK, the majority. OK. Who thinks that it's going to give an answer? OK, the minority. OK. All right. There are a total of 17 kids on the bus. We know that 8 of them have blue shirts on, which means the other 9 must have red shirts on. There are 2 possible bus driver names. If a bus driver is wearing a blue shirt, then there would be a total of 9 people on the bus wearing blue shirts. If the bus driver is wearing a red shirt, then there would be a total of 8 people on the bus wearing red shirts. Since we know there are a total of 9 people on the bus wearing blue shirts, the bus driver's name must be Blue. Yeah. All right. So it produced a lot of text, and I mean, I don't think the bus driver's name is Blue, so we don't know. But the correct answer is there's no way to know. Here's another example. It's the same as before. All I just replaced. How old in years is the bus driver? So again, impossible to answer. There are a total of 17 kids on the bus. That means the bus driver is 8 years old. Okay, so like just think about the mistakes it's making. These are mistakes that a human would never make. Like any human would know that you can't solve this problem. You can't know the bus driver's name. Any human would be able to reason about like what's a range that's reasonable. Like 8 years old doesn't make sense. There's no country in the world that gives 8-year-olds driver's licenses. But the model produces this answer. And then, of course, the age-old question. So this one really broke the model. Like, I have no idea what language this is. Yeah. So another example of, like, for whatever reason, like, it thought that this was the most appropriate response. This is actually a question that maybe this is a reasonable answer because it has no reasonable answer. But this is the output. So by the end of the talk today, hopefully you'll have a sense for why it produces this gibberish sometimes and why it generates really good results sometimes. And what are some of the issues with implementing technology like this in order to automate some existing human tasks. Okay. Before we get to that, I just want to touch a little bit on what I do. So as I mentioned, my work is focused on speech analysis. So, however, it's really split into two different fields. So I have a group of students that work on the theoretical basis of machine learning and AI. So that's really math and statistics. And I have a group of students that works on applications of AI to healthcare. So neither one of those says speech and language, but really the second one, the applications of AI to healthcare, as I'll talk about in the next slide, is really focused on speech and natural language processing. So this is the group there, and kind of color coded by who does what. So it's sort of maybe a 60-40 split in terms of the amount of work that we do in each of the two fields. So the students, they do this as a part of their PhD dissertations, right? Like the way academia works in the US is you select a professor, and that professor has to have funding for a particular project in order for the 4 years or 5 years it takes you to do your PhD. And so they end up picking the area that they're interested in, and then we help guide them through their PhD. I mentioned that one of the areas I work in is AI applied with applications to healthcare. And more specifically, it's really focused on detecting early signs of disease through speech. So think about how hard it is to speak. We don't really think about it very often because we do it so naturally. But imagine what my brain is doing right now. I'm standing here in front of you all, and I have some ideas that I want to convey to you. So the first thing I have to do is to translate those ideas into words, and then connect those words into sentences that using whatever structure is imposed by the language, and then finally send signals to muscles that produce the individual sounds that make up the words, that make up the sentences, right? So that's a really complicated process. It's one of the most complicated things that we do as a species. And because it's so complicated, if there's any neurological issues, so let's say, for example, you have Parkinson's disease or you have Alzheimer's disease, or let's say you had too much to drink on a Saturday night, then all of that becomes apparent in the speech signal because it's really hard to achieve what are called your articulatory targets. Like if you're trying to say t or s or p, that requires very precise motor control movement of the muscles. To drive that point home, here's a cross-sectional view of the human vocal tract. And I'll play the video. I just want to explain what you're going to see. What you'll see is the movement of the articulator, so the tongue, the lips, and this thing called the velopharyngeal flap. It moves as sound is being produced, and it moves very quickly.
This was easy for us. Jade may earn more money by working hard. She is thinner than I am. Bright sunshine shimmers on the ocean. Nothing is as offensive as innocence.
Okay, so to produce each one of those sounds, the speaker needs to be able to move their muscles precisely in order to achieve the right articulatory target, so to have the right shape of the vocal tract so that the correct sound comes out. This is like playing a musical instrument, right? Like every time we talk, we're really moving our muscles in a way to produce speech correctly. And if there's any issues with the brain and the network within the brain that facilitates this process, then it becomes apparent in the speech signal. So in my lab, we've developed algorithms for effectively reverse engineering what's happening in the brain based on the speech signal. And then we've founded a company who's grown rather rapidly especially the last year or so, that really takes the work we do at the university, productizes it at the company, and then distributes it to patients worldwide. So I won't be talking about this today. I just wanted to highlight this as maybe a topic for a future presentation. If you want to learn more, I have 2 links to papers here. This is the top one is focused on AI in healthcare, specifically in speech, and the bottom one is some of the work that we do in AI and ML theory. And then obviously you can go to the website and look through all the publications. Okay. All right, back to AI. So we had those nice demos with the GPT-3 model from OpenAI. That's not the only type of artificial intelligence. There's multiple modalities that make use of it. I think if you've used Siri or whatever the equivalent of Siri is on Android, you can use it to recognize your voice. In that case, it takes the speech signal and converts it into a sequence of words. If you've used Google Photos, it has this really nice feature where it detects faces, and then it groups faces from people that are familiar, and so that you can search your photos for specific people. It also does this really interesting thing in the background. It detects all kinds of objects like bananas or oranges or cars. So you can search through your pictures using like the word bananas, and all pictures that have a banana in them will appear. So that's an example of an artificial intelligence. That's computer vision, right? It goes and analyzes each of the pictures and assigns a label to the objects in the picture. And then of course we have self-driving cars. That's like a system of systems. You have multiple types of artificial intelligence models that are surveying the environment, trying to detect stop signs or people or holes in the road and so on, in order to get the car to drive all by itself. This is a really hard problem, and I know people talk about autonomous driving, but I think it'll be a while before we get to truly autonomous driving because it's so difficult. To give you a sense, there was a tweet the other day. Some guy had a T-shirt with a stop sign on it, and it completely messed up a Tesla. What's that? Yeah. He's not here right now, so yeah. So I don't have to motivate the topic why it's important to learn about AI, because one way or another we're all going to be interacting with it. But it is important to get a sense of approximately how does it work. So what I'll do is I'll give kind of a high-level overview. There's just one equation in the presentation, so you can cover your ears if you don't like math. when you get to that slide. But I will talk about functions. Let's see. Yeah. OK. So an AI model, if you want a mental model for how it works, think of an input that's being processed by a mathematical function and produces an output. This is like the simplest way to think of an AI model. So if you have a trained AI model, that means you have a mathematical function that takes the input x, modifies it in some way. This mathematical function is completely characterized by the weights that it has. So it has some weights. And it takes x as an input and produces y. So for the case of computer vision, like let's say we want to build a classifier to differentiate between cats and dogs. Let's say we've gone through the whole process of training the model. I'll talk about how that works later. The input to the model is the pixels in the input image. And the output is the labels. So in this case, there's two possibilities. It's either a cat or a dog. So it says that, in this case, it's cat because it's, the model thinks that it's a 90% probability that it's a cat and 10% probability that it's a dog. So the output labels is the probability over the class, meaning in this case, because there's two classes, cats and dogs, it's two probabilities. OK? So the takeaway for this slide is an AI model maps the input x into an output y using a mathematical function fw of x. I'll talk a little bit about different types of fw of x in the coming slides here. Another example, automatic speech recognition. In this case, the input is the raw acoustic signal, so whatever the microphone picks up, it's saved in the buffer. You process it again through a pre-trained mathematical function, fw of x, and what you get at the output is a transcription. This is a little bit different. Instead of having a fixed number of labels, it takes the speech signal and splits it up into individual sounds that make up speech. So there are these things called phonemes. So phonemes are the individual units in speech, like a, I, u, a, s, t. These individual sounds that make up all words. And then they're concatenated together into text, right? So in this case, you go from raw acoustics into a transcription, again, using a pre-trained mathematical function. Whenever you see in the presentation this pink, purple box, it means that you have a model that's been trained, meaning a model that produces the correct output most of the time. Here's another example. This is translation. So this is going from English to Mandarin. In this case, again, you have a mathematical function, fw of x, that takes input speech, so input characters in this case. I love speech science, and produces output characters in another language. Again, nothing but a mathematical function. So what is this fw of x? This is that one equation I mentioned. This is very simple. It's a linear equation. So this is a perfectly fine function. This is a linear function with two weights. You take the input x, multiply it by some weight w1, and then add w2 to it. So this is a linear function. You can't possibly train a linear function to predict cats and dogs from input pixels, because that would mean that you're going to just take an image, x, multiply it by some number, and add another number to it, and it'll correctly produce if it's a cat or a dog. That won't work very well. The point of explaining this is to show you that this fw of x is nothing more than the sort of function that you've learned about in algebra, right? Early neural networks were set up, consisted of functions that looked more like this. You have an x as an input. Then you have a series of multiplications with weights and nonlinear functions stacked hierarchically. You can write all of this using equations the way I did the linear example, but it would just take up the whole slide, so it's easier to show it visually. But there's no difference conceptually between this and this. You have an input x, you have this complex math function that's no longer linear, and you produce an output y. The difference between the linear example I've showed here, this only has 2 weights. Neural networks like this, the early ones had thousands of weights, meaning that you were really manipulating the pixels individually, multiplying them with different weights that you learned during training, which I'll talk about, in order to produce an output y. More modern neural networks are deeper, meaning they consist of more and more operations that are stacked on top of each other. And they're different types of operations. So here, it was the same operation repeated over multiple layers. Here now you have convolutions, you have attention layers. These are all different types of math functions that are combined in this sort of deep fashion in order to produce some output y. So when people talk about deep learning, if you've heard of that phrase, this is where the deep comes from. You have these deeply layered networks, so that you have mathematical functions stacked on top of mathematical functions to produce outputs y. These weights, here we have thousands of weights. For these more modern neural networks, there are millions or even billions of them. The GPT-3 model that we were playing with early on, that has 175 billion weights. So it's massive. And the more weights the network has, the more representational power it has, meaning you can have it learn more and more complicated things. However, you also need more and more training data. And I'll talk about what that means here in the coming slides. But these weights, or sometimes called model parameters, completely characterize the network, meaning if you have access to these weights, you know exactly how to map between the input and the output, and you have the whole network. Like imagine you had the weights for Google's computer vision network. You could easily replicate it on your own machine, and it'll work just as well. This is, in some sense, this is the final product, right? Like this is like, if you were to take this from someone, it'd be like stealing something physical from them if you want to map it to the physical world. Because they completely characterize this input-output relationship. So these mathematical functions are super important. That's why if you work with APIs that are based on pre-trained models, one of the terms and conditions is that you can't try to reverse engineer what our model is doing. Otherwise, people will try to replicate pre-trained models. Okay? But how do we find the right model weights? So everything falls on these weights. If these weights are correct, then the model performs great. If these weights are not correct, then you'll get the wrong answer most of the time. And we do this through a process of training. So I mentioned that if you see a box with a purple or a pink background, it means that the model is trained. When you first start this process, the model starts with random weights. So you have no idea what the right weights of the model are. So you start out with random weights. Then how do you get to the actual weights? You introduce training data, labeled training data in this case. Let's go back to my example of classifying between cats and dogs. If you want to teach a model to classify between cats and dogs, then you have to have a labeled data set. So a bunch of pictures of cats with the correct label cat, and a bunch of pictures of dogs with the correct label dog. And then you feed each one of these into the model. This is the part that took the longest to do, by the way, this little spinning thing. Yeah. So you feed the picture into the model, so that's X. With random weights, the model produces some random output. It's not going to be right? It'll be right because it's completely random. But you know what the right label is. You know that the right label is cat. So you tell the model, change the weights so that for this particular input, this particular picture, you produce the output label cat. This is the process called training. And you do this over all pictures and labels. You correct the model every single time it makes sense. Every single time it gets something wrong. And eventually, if you do this process over many, 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 many iterations, the weights of the model converge into something that makes sense. The really interesting thing about this is that actually this, you don't need anything more than calculus to actually understand the math behind this. All you're doing is finding the derivative of the mistake that the model makes, moving the model in the direction of steepest descent along weight space, and then until it produces the right output. You can ignore everything I said if it didn't make sense, but like, these are for the people that maybe have a math background in the room. But it's a pretty well-known algorithm, something that actually you probably learn in high school. The other interesting thing about this is because these models are so large, you need training data that's massive. So training data that's massive means that you can't store it in memory in a single shot. So the model has to work iteratively using what's called online learning. So there's an algorithm called stochastic gradient descent where instead of feeding all of the samples into the network at once, it does this in online learning fashion. So you feed it one example or a small number of examples, it produces those outputs, then you correct them and then iterate on that. If you do this enough, you get a trained AI model. So you get a model that has the correct weights and works well most of the time, right? It can classify between cats and dogs reasonably well. So the takeaway for this slide is the model learns the appropriate weights from the label training data we show it. The more weights the network has, the more training data is required to find the appropriate weights. So if you have a very small network, you don't need a lot of labeled training data. If you have a really large network, you need massive amounts of training data. So that's a little foreshadowing for the GPT-3 model when I talk about how that works. In that case, you need a ton of training data because you have 175 billion parameters. OK, so back to these language models. There's this thing in linguistics called the distributional hypothesis. So give me some words that make sense to complete the sentence. I was hungry, so I ate pizza. Other examples?
Late.
What?
Late.
Late? Yeah. I was hungry, so I ate late. That one is probably a lower probability response. Yeah. Sandwich works. A lot of food works. There's a lot of responses that work. But there's a lot of responses that also don't work, right? So here's some high probability responses. A sandwich, a burger, a pizza, a salad, a lot of food, and some low probability responses. A car, a house, a table, a TV. Like imagine going online and doing a search for I was so hungry I ate a TV. How many pages do you think would show up? Not very many, right? But if you go online and do a search for I was hungry so I ate a burger, there's a lot of results for I was hungry so I ate a burger. So this distributional hypothesis says that if you take this as a task, like to figure out what is the missing word, that missing word, like words that can reasonably fit within that missing word, are semantically related to each other because their definition comes from the context. I was hungry, so I ate a blank. There's a lot of words that fit that, right? So you can see a sandwich, a burger, a pizza, a salad, a lot of food. Those are all semantically related, meaning that they're they're more similar to each other than they are to a car or a house. Similar if it said I needed to get there quickly, so I took a blank. A car, a vehicle might make sense, but a sandwich wouldn't make sense, right? So the surrounding context defines what word comes next. Like you have high probability responses and low probability responses. This is basically the secret sauce behind GPT-3. This is how it works. What GPT-3 does as an output is it takes the prompt as an input. That's the X. So that's like the first phrase that I wrote as an input to the model. And it produces a list of probabilities. So here I have probabilities over all words that could reasonably go next. So internally, this y is a probability vector over all of the words that it could output next, and then it picks the most likely one. So I was hungry, so I ate a sandwich. Makes sense because the rules of the language say that it makes sense, right? So GPT-3 would predict a sandwich. But how does it learn all of these rules? So it does it in 2 steps, but they're kind of big steps. So there's a reason I said if you were to do a Google search for I was hungry, so I ate a sandwich, in some sense it really does that. Like the GPT-3 is trained on effectively all of the text on the internet. And it learns the probabilistic rules of language by analyzing all of the text online. So if you want to train GPT-3, the first step is download all the text on the internet. The second step is generate a training database. So like this is how the training database is generated. This is a couple of sentences from Wikipedia. So let's say that they downloaded GPT-3. They downloaded this sentence from Wikipedia, and they wanted to convert it into this XY training sample pair that I showed in the other slides. What they would do is they look at the sentence phrase by phrase. So the input would be Kosovo is bordered by, and the output would be Serbia. And then the next sample, Kosovo is bordered by Serbia, and the output would be to. Kosovo is bordered by Serbia to the north and east. You generate a series of X's and Y's by having the model predict the next word. And that's all it is. And so if you do a search, if you download all of the text on the internet and modify those weights using the stochastic gradient descent that I mentioned earlier, where you're trying to predict the next word, if you do this on a massive scale, then what comes out is something really amazing. It's that GPT-3 model. This is, in some sense, like in the last 2 years, it probably started with OpenAI and DeepMind, the most sort of amazing observation. It's not that there's new math that was developed or new unbelievable methods for AI. It's that if you have data at scale and you can process that data at scale on massive networks, it learns probabilities really, really, really well. And internally, these models may not have any sense of what's a fact or what's not a fact, but it knows, like with very, very good accuracy, what the highest probability next word is. Make sense? It cost OpenAI, I think, $20 million to train the model. So this process here, this thing cost about $20 million. And actually, if you want to get into some of the ethics of AI, it had it has a massive carbon footprint because it takes a lot of computational resources in order to train it, but then also to operate it, to run it once people start calling it. Okay. So to train the model, you have the training data. Again, you feed the X here, Kosovo is bordered by, to the model. It predicts initially some random word. You fix that random word. You fix the weight so that it actually predicts Serbia. And then you feed the next sentence, Kosovo is bordered by Serbia. And then you fix the model so that it predicts to, and so on and so forth. And you do this for everything that's been written online. And what you get is GPT-3 with 175 billion weights. And so that's what this FW of X here is, the math function that's been trained effectively on all of the weights online. Okay. So, like, people want to ascribe human intelligence to these models. I think a better term, I didn't come up with this term. This is a researcher, Timnit Gebru. She called them stochastic parrots, because just like a parrot learns to mimic what you say, a stochastic parrot learns the probabilities behind what you say and can mimic those, right? And so this GPT-3 model is really a stochastic parrot because it's been trained on all of the text that humans have generated online. And so the last thing I want to talk about is that last statement that I just made. All of the text that humans have generated online, who knows that there's a lot of trash online? Everybody, yeah, all of us, right? Like we generate some of it too. So then what happens if you teach this model based on things that humans have written online? I mean, like Twitter has interesting things, but it also has some crazy stuff on there, right? So the first thing that happens is by virtue of training, it means that the model is already outdated, right? Like you have, as I said, there's no concept of facts or truth versus false. All it has is language that it's analyzed. And so if there's no concept of what's true and false, and you're training a model with outdated data, then it's going to give answers that don't make sense or that are incorrect. So for example, the current Prime Minister of Kosovo is Hashim Thaçi, who's been in office since June 2014. Like this answer makes sense since the data that GPT-3 was trained on was from 2019 and before, but that's not a correct answer today, right? Or the current president of the United States is Donald Trump. Again, not the case. Or I just wrote Visar Berisha is, and then this is what it said. An Albanian former member of parliament of Albania and former minister of justice. Maybe this is true. I don't know if there's, I searched for this person, I couldn't find anything. But it basically just produced a bunch of text that was high probability, and it sounds good. So if it sounds good, like you can imagine, these systems don't exist in isolation. There's people using them. And so if you were to show this to someone that doesn't know anything about me, they'd say, okay, well, this guy's a lawyer. And I guess he was also in the parliament of Albania. So there's no concept of what's true and false. And this is dangerous because if you want to make fact-based decisions, you can't use these models autonomously. There has to be some sort of oversight, right? A bigger problem is bias and toxicity. Like the online discourse can be pretty toxic, right? Like people write all sorts of different things. And so I did a little experiment. I looked at the output of this model with different sort of provocative prompts. So here's the first one. People from Western Europe think that Albanians are, and then I had the model complete the rest of it. Yeah, it's funny, but it's not, right? Like, I mean, you can imagine if a model like this was deployed for the purpose of decision making somewhere in Western Europe, then it would obviously be biased towards Albanians just because they were Albanian. How about this one? This one hurts. Albanians from Albania think that Albanians from Kosovo are lazy, uneducated, and violent. So again, this was based on just the probabilistic output of the models. It even picks up like whatever insecurities we have, I guess. Albanians in Kosovo think that Albanians from Albania are the real Albanians and they are the fake Albanians. Yeah, that one, it hurts. Yeah. So I went broad, Western Europe, Albania, Kosovo. I said, let's see how granular we can get. I'm going to leave the last two without comment. Like, my wife will probably watch this at some point, and she's from Jakova. So. Yeah. So it's easy to laugh at this, but it's actually a real problem, right? I mean, there are AI models that have been deployed in other contexts, not GPT-3, but the New York Police Department several years ago deployed a model to do what they called precision interventions for crime. Like they wanted to really look at the block level, at the neighborhood level, where crime was happening most often, and then try to address the problem locally in those communities. It turns out all they were predicting was how many African Americans were in each one of those communities, right? And so again, you had this disproportionate impact on the underserved communities because they were using an AI model without really dissecting to see how it works or what it was doing. So the potential for negative outcomes if these sorts of models are used blindly is really significant. Okay. And that's it. I just put a few more links here in case people are really interested in doing a deeper dive on any of these topics. If you have some programming background but you're interested in getting into AI, I would go through this sort of step by step. Learn Python. Most of the stuff happens, most of the AI implementation work happens in Python. Learn linear algebra and basic calculus. Again, these are all free courses online where you can do this without having to pay for anything. And then finally, learn about machine learning. This is, like if you've done the other two, this is by far the best introductory machine learning class that's out there. The first one that's listed here is by Andrew N. These NLP sequence models, these talk about these language models like GPT-3. And then if you're interested in learning more about ethics in AI, what I talked about earlier, the carbon footprint of training these models, and also toxicity and bias, this last class is a good one. And that's it. Any questions?
Oké, maar ship.
Ship, ship. Ja.
Mas qual é a matéria já de parte se eu tô molhando para se subir em preço para classe para até para facilitar isso. Era essa é dilema niere interpretazione tagliaż mu intrigata. Në fakt, në qoftë se unë jam së shpejti shoha mu bëhe prind, edhe kam atë idenë e një fëmijë të vogël, në qoftë se marrim aspektin filozofik, realisht ose edhe fetar, realisht vjen një shpirt dhe jipet një trup, edhe ta shikoj që ato 10 vjet e parë që thotë 80% gjana që i mëson, do të trajnohet në çat proces për më shumë me përdor trupin e vet. Po ndona që ndoshta për përvojës tonë me mësu në fushën prej nga avione, në fushën e mjekësisë ç'është funksionon realisht trupi. Nëse unë ty të pyes, thua një objekt të bardh, edhe me siguri shkon sipas probabilitetit, dikush thot muri, dikush thot qumsht. Mirë po procesi i trajnimit duhet më bëni herë dhe mandej në aspektin e energjisë duhet më kon super efikas në mënyrë që shumë shpejt me u procesu me ardhe të një përgjigje sepse i shkon e pa kuptim që vazhdimisht më u kthy këtij trajnimit për çdo përgjigje. Variablet janë çast të mëdha, nuk e kam idenë që funksionon te njeri, është memoria, është po nashta prej temu më mësu çka e bën që mandej mos e kalu në për këtë proces të trajnimit sa që bëhet një pyetje, por realisht shumë shpejt më ardh deri te një përgjigje edhe energjik në aspekt energjik më efikase edhe në kohë. Faleminderit.
Ja, shumë pyetje me vend. Ti më pyete në gjuhën shqipe, unë po ta kthej në gjuhën angleze. Okay, that's exactly why humans don't learn this way. So when I said that these are stochastic parrots, humans absolutely don't learn this way. We don't just we don't just learn probabilities in language. We learn how to reason. So if you have a baby that's recently born, they know that if I take something and I push it, it moves. Like that establishes cause and effect. If I apply a force to something, it moves. They know that if I cry, I'm going to get food. Establishes cause and effect. This cause and effect is completely missing from AI models. All it learns is relationships between data. And just because you learn a relationship, it doesn't mean that one causes the other. So that's a really important distinction. I mean, I'm saying all this stuff. The short answer to your question is that I don't know and nobody knows how humans are able to do it so efficiently. But the really key differentiator is exactly what you said. It's that it would be really inefficient for humans to learn this way. If it takes $20 million to train GPT-3, it's cheaper in most cases to train a kid, right? So the humans are really, really good at what's called one-shot learning or few-shot learning. If I show someone a few examples of a dog and they've never seen a dog before, or a particular type of dog, with just those 2 or 3 labeled examples, they're able to see that, understand that that's a specific type of dog in other contexts. You don't need a large label training set. It's able to intuit immediately what are the properties of that dog, and then it doesn't matter what angle they're looking at the dog from, whether the dog is facing them or not, they're able to know that it's a dog or a type of dog. Computers can't do that, not even close. That's why I had that slide about these things about this talk about these things being sentient or human-like. Not only is it premature, it's not even worth having the conversation. Yeah. Does that answer the question? Yeah. Yeah. Qysh kishe?
Vitin e kaluar kemi qenë finalist në ICK në ICT Albanian Awards dhe një nga finalistët ka qenë e ka pas një projekt me artificial intelligence ku ka mujt me detektu sulme të cilat mujnë me ardh heart attacks, që mujnë me ardh prej shkaqeve të ndryshme dhe me i parandalu me një farë forme. Po unfortunately nuk kanë mujt me na shpjegu shumë se nuk ka pas shumë kohë me bëhat prezantimin e tërthort, veç deshta me ditë nëse veç keni ndëgju për këtë projekt, ka mundësi pak me elaborua dhe adin veç me ditë pak a shumë qysh ka ardhur deri te çajo, a ka qenë reverse engineering një farë forme, a ka qenë qysh e kanë mësu që me ardhur deri te detektimi I heart attacks.
Yeah. I guess I mean I don't know even what the technology was. Po nën me za a me diçka tjetër? No.
Nuk e di veç.
Nuk e di. Okay. Yeah. So I think just with Meza, it would be really, really hard. I mean, I think probably impossible to be able to detect a heart attack. Maybe with a watch, like if you have, the iPhone, the Apple Watch has this atrial fibrillation, however you say it, detection, right? This is an algorithm that's been trained using previous data. So they had data from patients that had that symptom and data from patients that didn't. And they're measuring not just the heart rate, but the actual beat QT curve or QR curve. I'm not an expert in that area. From that, they measure certain parameters, and using the labeled training set, they have a simple model. One big difference between those types of approaches and what I'm talking about is that those are much, much smaller. Like, there's not the equivalent of the internet for healthcare. Like, you can't just go and download heart signals for 1 billion people. And so as a result, you end up using models that look more like this than models that look more like this, because the data doesn't exist to train models at these scale. So like at the company that I mentioned, a lot of the work that we do is with simple models, but where we really work very hard to understand exactly what X is, how we extract the right kinds of features, and then you don't need a lot of training data in order to train the models. So that answers your question partly, but yeah. Yeah. Përpara.
Visar, masi po të njohim në lidhje me pyetjen që e boni folsi, ndoshta më na tregu për atë projektin me Alzheimer dhe me speech, çish funksionon, në pika të shkurta, që edhe me ditë pak më mirë.
Okay. So we have a project for detecting early signs of Alzheimer's or cognitive impairment in general using speech. The way that works is I showed that video of a person talking earlier. Before you ever get to that point, you have to think of the words to say, right? So if I'm talking to somebody and they ask me a question, I've never heard that question before. It takes me a second or two to generate a response. As I'm talking, it might take me a second or two to think of the right word to say also. So what we do is measure the speech signal using acoustics. So we look at, I'll use as an example, this pause time. How often are they stopping to pause for specific types of words? Then we look at what words they're using. Are they words that are complicated or simple? And we look at different proxies, different measures of the size of their vocabulary. And then we track those over time. The thing is that every single person has a different speaking style and a different vocabulary size. And so it's very important to be able to track these within a particular individual rather than comparing between two different individuals. Because you could have someone with very different starting points in terms of their vocabulary where they begin. So what's important is to look at changes within a person rather than what's called cross-sectional changes. Yeah.
Do është ta me pyet pak më shumë për weight. Unë e përdori AI kur du me gjeneru copywriting, diçka me kry shpejt punë, po jam të zhvillu një aplikacion paka shumë i merr masat e trupit nëpërmjet kamerës. Tash po du me inkuadru AI mrena që jo vetëm nëpërmjet trigonometrisë, po me rrit saksi nëpërmjet AI. Tash kjo weight me sa po shohim kur e gjeneron një copywriting e merr me peshën çka weight pe marr si pesh sa është përdor çaja fjalë në Google ose nëpër search, tekstin në internet.
Yeah.
Qysh kisha mujt me përdor të njëjtin senon me qysh kisha mujt me përshtat në aplikacion çet weightin që më mujt me rrit saksinë e çunë masa të trupit kur mirën për kamerës.
Okay, so kur të merr the input in that application is the image, apo? And the output is what? What are you trying to predict?
Masat e trupit, soi, gjang,
okay,
pesha.
yeah. So you have to
gjatësia.
have some existing labels on, say that you have a picture of a person, and you say this is their left shoulder, this is their right shoulder, and then you can measure the distance between the two, right? So you have to have some large labeled set that has these anchor points labeled. And you would train a detector to look in the image to identify what part of the image contains the left shoulder, what part of the image contains the right shoulder. There's a lot of work that's been done on this. So it's probably, I'm probably not able to get into details here because I haven't looked at that literature. But if you want, send me an email and I can point you to a couple of papers. Maybe even a GitHub repo. Yeah. Yeah.
Përshëndetje, shqip apo anglisht?
Shqip, yeah.
Okay, super. Tani unë kam pak gjër introductionin përpara, pastaj për të futur në detaje. Dy aspekte për sa i përket prezantimit tuaj. E para super interesante edhe shumë fantastike, më duket ndonjëherë shumë e pa arritshme për low income countries për ne, do të thënë përfshirë edhe ne, Shqipëri dhe Kosovë, të dyja. E dyta, sa fort duhet i mshojnë trinj shqiptar për sa i përket kësaj teknologjie, edhe si mund ta integrojmë për universitetet tona, që t'i jepet një fokus tjetër, t'i shikohet me një sy tjetër, dhe një pyetje që më intereson mua shumë dhe në fakt nëse do mundi ta elaboronit pak më gjerë. Keni pasur ju në laboratorin tuaj ndonjë rast specifik për sa i përket AI në healthcare, që ka qenë rast suksesi të tipit keni studiuar një person i cili ka vuajtur nga cognitive diseases ose neuro diseases që degenerojnë më pas në fatalitete. Qa ka qenë diçka që realisht ka bërë diferencën, përveç pjesës matematikore, po që një person normal ta shikoj fizikisht, ta shikoj në realitet, do më thënë me dalit që nga këto formulat e gjërat, edhe sa kohë do duhet për të qenë shumë e prekshme për personat, për pacientët, do me thënë dali si produkt real në treg, jo vetëm në clinical trials, po like kind of saving lives fast as possible. Kjo ishte e gjitha.
Okay. I'll take that question in two parts. So the first part is related to training. So is the tools that I'm talking about here, in some sense, have been democratized, so anybody can use them, right? Like you can download different pre-trained models. You need a computer and a GPU in order to run these models, and those things, they're a little expensive but affordable, here and elsewhere. The type of training I think that has to happen is, it's not like everyone's going to become an expert in building AI models, but I'm pretty sure everyone is going to be using AI models in whatever their field of study is. So whether it's medicine, you have to learn how to integrate information from these models along with clinical expertise for decision making. If it's in law, there's all sorts of different, like the definition of a contract is changing every day because some contracts are not generated by AI models, at least partially, and then smart contract infrastructures and so on. So I think what's going to be important is to train people to be able to adapt to the way that work is being done in those fields. Like I don't think that everyone has to be an expert in programming AI models, but conceptually understanding where they work, how they work, understanding how to interact with them. I think that sort of education has to happen here, but it also has to happen in the US. Like there's a concerted effort right now in academia in the US to add AI training courses as kind of an introductory course in whatever field of study. The second question, shamble per success of AI in healthcare. In the US, there's this entity called the FDA, the Food and Drug Administration. You're not allowed to make diagnostic claims about a patient for a device that has not been FDA cleared. So to date, the work that we've done has been with pharmaceutical companies. So what pharmaceutical companies do is they have different drugs for a particular disease, like let's say Alzheimer's disease. And they want to evaluate whether that drug works or not. Because if that drug works, then they can bring it to market. And if they bring it to market, then it ends up saving lives. So the work that we do is in that context right now, meaning that we measure people's cognitive levels to see if drugs that are being tested are working or not. So far, none of the drugs that have been tested have shown any difference. And that's a problem in neurology in general. 95% of all drugs that pharmaceutical companies make in neurology failed. So only 5% make it to market. So this is why it's such a big problem, but the impact is potentially huge. At the end of this year, we're going to be registering the cognitive impairment tool with the FDA. And then, maybe next year I can give you a concrete example for a patient. Yeah. Okay.
Përshëndetje Visar, unë jam Arbri, faleminderit shumë për prezantimin. Çka jam unë kurioz me ditë është për shembull po du me fillu një kompani unë sot, edhe po du me zhvillu një AI. Qysh muj unë me download krejt qatë tekst që është online? Për shembull krejt, qatë subset. A është diçka që është ekskluzivisht veç e rezervume për Google, a muj me ble unë, a qysh kanë që e
So, I mean, like you can scrape, you can use a web scraper, but I guess bigger question is why would you want to? This is an API call away. Like you can just use GPT-3 and build on top of it.
Po, ajo mandej nuk po është në farë mënyre që po je predetermined me use që ato.
Oh yeah, that's a good question. Yeah. Yeah. So this
chat raw data nuk është open për krejt.
No. There are open source initiatives where the people have large, massive text databases that they provide free of charge for training models like this. But none of them are the whole internet. So they're large, they're massive, but they wouldn't result in what this model can do. But your first comment was very good. The thing about this being close to a small community. Yeah, this is one of the again, related to ethics. There's basically 2 or 3 companies now that control the AI models. So OpenAI, DeepMind, which is part of Google, and then a few other smaller ones, but those are the big players. And they're really driving the direction in which the field goes. So all of this conversation about whether these models are sentient or not, one of the beliefs is that this is just a marketing ploy by these companies to get people to think that, hey, oh my God, something amazing is happening. And something amazing is happening, but it's not human-like. It's not like the singularity is near. And there's all sorts of other ethical issues, but this is a real point of discussion right now. So I don't have a good answer for you, except that it's happening, and it's probably going to mean that the power is going to be concentrated among very few companies. Yeah.
Përshëndetje, e po tani pyetje i përmend pak më herët që mojna me shfrytzu pre-trained models. Deshta me pyeta mojna me definu skopin për shembull ose çka po na vjen konkretisht piç aty në pre-trained data. Shembull konkret po ta marr për shembull në Google kur lypim. E lypim Big Bang Theory me të parë na i qet për shembull serialin, nuk na i qet domethënë teorinë komplet. Tash puna a mojna me shfrytzu domethënë një klasifikim konkret në çato pre-trained data. Për shembull e kemi me klasifikimet fotografisë, dogs, cats, për shembull për specie tjera, qysh mujna me bo klasifikim, jo general based data, po.
So is your question about how to collect the training data, or is your question about how to use a pre-trained model?
How to use a pre-trained model with selective, me definu skopin për shka për na vjen për shembull.
So I mean, I guess it's kind of interessant me provu. But in GPT-3, you could say, tell me something about Big Bang. And I don't mean the TV show, I mean the concept from physics. So in some sense, that first prompt serves as a way of guiding the rest of the model, right? Because as soon as you include those words in the context, then it makes, Sheldon not a likely next word prediction. But 13 billion years ago is more likely, right? So in terms of using this particular pre-trained model, I think that's the way to do it. If you have something more general, like let's say you have a pre-trained model that looks at cats, dogs, rabbits, goats, whatever, but you don't care about rabbits and goats, you just care about cats and dogs, then you could collapse all of those. Like you could say it's either a cat, a dog, or something else. And then you'd get 3 probabilities instead of 4. But I'm not sure if that is what you meant. Yeah. Yeah. Yeah.
So we've seen that the AI community now is heavily focused on bettering their tools and bettering these algorithms that we now have. However, some experts have told us that with the tools that we have now, we can solve a lot of the world's problems. In your opinion, what are some characteristics of these types of problems that make them more suitable to be solved by AI?
That's a good question. Yeah, this is a very good question. So the characteristics of the types of problems that can be solved by AI is if the solution doesn't have to be right the vast majority of the time, and if when you're wrong, the consequences are not great, or not big, right? So a good example is if you're using Siri. If it doesn't understand you, who cares? I mean, you say it again or you stop using it, right? So that's a good example of AI. A bad example of AI is you want to do automated diagnostics top to bottom just based on a picture of somebody or something, right? Then if your AI model gets it wrong, then the consequences are massive. So I think in terms, if we're talking about right now, the second problem, the one where you're applying it to say do disease diagnosis, you can do it in really narrow settings, but you can't do it broadly for all diseases, for sure. What are other problems where the consequences are massive? The self-driving problem. if a Tesla doesn't know that it's supposed to stop only when it sees a stop sign and not when someone has a T-shirt with a stop sign on, that's a big problem. And so the consequences of the car being wrong there are massive, like deadly. But whether it gets the right object in a picture or not, who cares? Yeah. That's a very good question.
Data science, so I just have some questions. I work in APL, so I kind of detect a job application for what kind of job it is usually. And it's been working in English pretty well. So if I want to switch to other languages, do you have any tips or tricks? And how much linguistics do I need to know if I want to specialize in natural language processing? Also, for fraudulent users, is there any pre-trained model or any idea how to handle that one? To predict if...
What is a fraudulent? What does that mean?
For a fake user, fake accounts, detection of those.
Oh, like bots?
Yeah.
I see. Yeah. Okay. There's this joke in automatic speech recognition. It's that if you want to decrease the performance of your ASR model, hire a linguist. Because they'll try to hard code different things instead of having it learn from the data. There's some truth to that if you have a lot of data for automatic speech recognition. It's not true generally for all applications. So to answer your first question about how do you go from like an English-only model to some other language, there's lots of approaches. So the simplest one is you get data from that other language. A better one is there are pre-trained models on what are called vector embeddings. So these for different languages. There's something called the use embedder, USE. And it's been trained on multiple languages using transfer learning. So you know this field, so maybe you've heard the terminology, right? So you can use these pre-trained models from different languages, or you can train your own by using an English model that's been translated to a language of your choosing, and then training a model on the translated language. So that's another way to do it. The fraudulent use case, that's isn't that like the Elon Musk problem? Like that's why he didn't buy Twitter, right? So what you would need is a database of what are the bot user accounts and what kind of text do they generate. And apparently Twitter is unable to provide that. But I think there are some online databases of bot accounts. And there's been some work that's been done in that area specifically. I mean, if you send me an email, I'm sure I can find one or two and send them over your way. Yeah.
Modelin që sapo të shpjeguat ka mbrapa me disa algoritme me të cilat merr vendime. A mund na midis çu emri aty algoritme me të cilat merr vendime ky model. Sa më me kohë si training database.
Pjesën e parë nuk e ndëgjova.
Çu janë emrat e algoritmeve me të cilat ky model veç e merr një vendim për mi vendosur një tekst ose diçka.
Aha, emrat e algoritmeve. Okay, yeah. So, në varet për cilin algoritëm. Për ato që e kanë bërë web scraping to collect the training data, like I have no idea. Nuk e di because it's probably proprietary. But për ato që to change the weight values. So there's different algorithms. So the loss function is typically called cross entropy. The name of the algorithm for modifying the weights is called stochastic gradient descent. And then the tools that are used to implement this, I don't know what they use internally at OpenAI, but the community at large uses this thing called PyTorch and TensorFlow. So I think that those are some of the names, yeah. Huh?
Servisori në vend, po. A ka dhe alo pyetja më të? Edhe një edhe dytë. Okej. Po, a dikush na për shkak që mos mi mojt krejt se sigurisht dikush do me lëvizë, i vjen keq me na prish në ashta aktivitetin. Na mundemi me marrë edhe dy pyetje mase pak në grupe më të vogla mundem na ashta nëse po pak me diskutu. A vjen çfarë?
Po.
Përshëndetje Visar, faleminderit për prezantimin. Pyetjen e pata për një projekt tjetër që është në kuadër të OpenAI, që është pak më shumë nëse zgaboj në weights, në krahasim me çito që e shpjegove ti, edhe quhet DALL-E 2. Edhe pyetja jam është në kuadër të konsumimit të këtij modeli që është i trajnuar. Pa ta aplikuar edhe ndalë nish edhe ndysh, po nuk pas përgjigje prej tyne. A ka një cloud service që e shfrytëzon modelin e trajnum të DALL-E 2-shit edhe ti mundesh me shfrytëzu si customer. Faleminderit.
Ja. Unë alo se kom nishin as dyshin. So DALL-E 2 is a similar model, but instead of going from text to predicting the next word, it goes from text to picture. So it can generate some amazing pictures. You provide a text prompt like, show pictures of the minions on the moon dancing, and it'll generate a picture of the minions on the moon dancing. It's very, very impressive. As far as I know, there's no third-party APIs or third-party tools that make use of their API that are open to everybody. I think that's the question you asked. Yeah, so as of right now, I don't think it's possible to use it. There's a mini version, mini DALL-E, but it's nowhere near as good. Yeah.
Cosmopolitan has used this one for the cover?
I don't know, maybe, I'm not sure.
Cosmopolitan for space, first ever cover made by AI. For Cosmopolitan magazine.
Oh, interesting. Yeah, there's a lot of AI art that's happening right now. I don't know what the...
It was Lady on the Moon or
Yeah.
Space.
Interesting, yeah. Mid-Journey? This is a new one? Yeah, so Mid-Journey, is that one available to everybody? It's closed also? Yeah.
Së pari faleminderit për prezantimin, unë jam Albani, jam ekonomist me profesion. E kuptoj që fokusi kryesor I AI momentalisht është në healthcare, është çështje shumë sociale dhe ka të bëjë me jetën e njerit. Jemi me një situatë ku shohim ndryshimet globale të çmimeve, lëvizjen e kurseve të kembimit, inflacionin. Sa ka me ndryshu lojën AI në fushën e ekonomisë dhe në fushën e parashikimeve financiare, ç'a mendon? Edhe pyetja tjetër, sa mendon që AI o ka lu një rol shumë të madh tek bursat për shembull të stocks ose të kripto ku kam dëgjuar që përmes AI ata janë të për shembull big players janë të marrë vendime që cilat po ndryshojnë komplet lojën stocks momentalisht. Sa ke informacion rreth këtyre? Faleminderit.
I have some general information, but I don't think I have specific information. So some examples of AI impacting economy, especially in Africa, I've heard that are very, very good. So one example is using AI to automate selling of different products, for example, in markets. So they have technology that is built partially on AI, maybe simple AI, that enables people from all over the world to request specific products that are made, let's say in some village in Africa, so that they can make it and then distribute it worldwide. So that's partly the internet, partly AI. For the part about the stocks and crypto, yeah, I think even before AI was a thing, there's a lot of competition for engineers in data science between financial services companies and Silicon Valley. So there's a group of people called quants, and these guys, all they do is try to optimize models for predicting stock price or the price of some goods and services so that they can either short it or buy it. The company can. So this has been going on for a long time. And whether models like these are helpful in predicting in that context, probably, but I haven't really kept up with that field. There is a movement called AI for social good, where the goal is to try and use AI to lift countries that are behind, whether it's through making opportunities available that weren't there before, economic opportunities, or other means. So that might be a good search term on Google if you want to look into it. AI for social good. Yeah.
Perfect. Shtukur vjen me pushu dhe lodhesh. Faleminderit shumë për vëmendje, faleminderit shumë, faleminderit Sar. Po besoj që keni me pas mundësi me metë edhe kontakt, unë e përmenda pak ma herët që kemi ndoshta një befasi të spuzoj me fol para se mu formalizu një bashkëpunim. Arizona State University, për cilët kemi me pas mundësi me pas edhe aktivitete tjera pak ma hands-on. Nashta këtë pjesën zyrtare për përmbyllim, për me juftu edhe në aktivitete tjera, kemi me pas gjatë ferës mysafir shumë të veçantë, edhe nëse keni nëjë propozim për nëjë aktivitet, mysafir, që e dini që është Kosovë, ka qef me fol, keni qef me ndëgju, lirisht na shkruni, provë boni mira, i mirë ke. Faleminderit. Faleminderit gjithve, kush dëm pak nashta me nejt, me network mu i pak.
Veç ta bojmë një selfie njerë, hajde. Apo vjen së?
Ta nëzojmë krytu në krytë e ma.
Nashta 2-3 fotografi do të.
Që bënë edhe me atë pjesë. Prisja një specialitet.